Hello, the goal of this video is to introduce quadratic equations and to show how to solve some of them. Quadratic equations are equations that can be written in the following form: ax squared plus bx plus c equal to 0. Equal because this is an equation. And quadratic is because we have the exponent for the variable x to be squared. Here we require a to be a number different from 0, and then a, b, and c are just any real numbers. We want a to be different from 0 because if we remove the a term, so if we multiply 0 by x squared, then we will be left with bx plus c equals 0, and that's a linear equation. When I first say the definition a few seconds ago, I said that they are equations that can be written in this form. So initially, they don't need to look exactly like this, but we should be able to transform them so they look on this form. For example, I'm going to write here a quadratic equation that is not looking exactly like this at the beginning, but we can write it like this. If I say, let's x plus 1 times x plus 2 is equal to 0, it doesn't exactly look like my definition, but we know that we can apply distributive property here. We need to multiply all terms from the first bracket against all terms from the second bracket, and then we will get that an equivalent way of writing this is x squared plus 2x plus x plus 2 is equal to 0. So this can be written as x squared plus 3x plus 2 is equal to 0. So we did manage to write it in the form we wanted. Here the value of a, that's the number multiplying x squared, that will be 1. The value of b, that's the number multiplying x is 3. And the number of c, that's the number that doesn't have any variable, that's equal to 2. So this is an example of a quadratic equation. Initially it didn't look like one, but we could apply the distributive property and write it on the form that we want. I'm going to also write down an example. Let's say I write x cubed plus 6x squared minus 2x minus 7 is equal to 0. That's not a quadratic equation because we have this term in x cubed that is not allowed in the definition. We will define now what a solution is for a quadratic equation. Well, this is a value of the variable x, if my quadratic equation is written in x, such that when I substitute that value in my equation, the result is really 0. For example, if I write here for the quadratic equation x squared plus x minus 6 is equal to 0, the values x equals minus 3 and x equals 2 are solutions. And I want to show that this is true. So I want to write for x equals minus 3 what the expression is going to look like. So I'm going to have minus 3 squared. I am writing minus 3 instead of x, plus minus 3 minus 6 is equal to 0. That's what I want to check if it's true. So in the left-hand side, I have 9 minus 3 minus 6, which is really equal to 0. So we verify that x equals negative 3 is a solution for our equation. Let's check that x equals 2 is a solution as well. So we have to write 2 instead of x, so I have 2 squared plus 2 minus 6. I'm asking myself if this is equal to 0. Note here that I didn't really need to put the brackets, I just put the brackets to make sure that if there is a sign, I won't forget it. So let's see, in this case, I'm going to have that 4 plus 2 minus 6. That has to be equal to 0, and it is indeed. So this is a solution. Quadratic equations can have 0 solutions, 1 solution, or 2 solutions. So let's write this as a comment here. Note, a quadratic equation can have can have 0, 1, or 2 solutions. We say that we solve a quadratic equation when we find all of its solutions. And that's what we're going to try to do now, at least for some special cases. So the first special case that I'm going to look at is when the quadratic equation is given in factorized form. In factorized form, it means that we are going to have it as a product of linear factors. So this is factorized form. So we are going to have a bracket with a linear expression multiplied by another bracket with a linear expression. This is equal to 0. For example, we could be writing x plus 3 times x minus 5 is equal to 0. This is a quadratic equation. It's like the first example we look at, because if I expand, I'm going to end up with something on x squared. And if we want to find the solutions here, we can use a very useful result that is called the null factor law. This makes really easy to solve this type of equations. What this law says is that if we have two expressions a and b being multiplied by each other and equal to 0, so if a times b is equal to 0, then for this to happen, the only way is that either a is equal to 0 or b is equal to 0. That's very logical, right? If we get a result of 0, it's because we already were multiplying by 0. So this is an extremely important result because it makes our life much easier. So if we go back to our example here and we apply the null factor law, what we are saying is that if the result is equal to 0, then either the expression inside the first bracket is equal to 0, or the expression inside the second bracket is equal to 0. So this is applying the null factor law to our example. But the good thing about this is that these are linear expressions, so we know how to solve them. So if x plus 3 is equal to 0, then that means that x is equal to negative 3. And if x minus 5 is equal to 0, then that means that x is equal to 5. So we found the two solutions for our equation. Let me write another example here. So what I want here is to solve by applying the null factor law. And I write NFL for short for null factor law. And actually, let's make two parts from this. Let's say that I have one of them. It says that x minus 7 times x plus 20 is equal to 0. Okay, I have two brackets that are being multiplied and the result is 0. Then one of them has to be equal to 0. So, by the null factor law, the possible solutions are either that the first bracket x minus 7 is equal to 0, which means that x is equal to 7, or the second bracket has to be equal to 0. X plus 20 is equal to 0, so x has to be negative 20. So those are the two solutions for our quadratic equation that was given in factorized form. Now, I can write this as complicated as I want, but in any case, I always have some linear factor inside my bracket, so it could look crazy, but still it's not going to be bad to solve. For instance, I can write that 3x minus 17 times, and here I'm going to make it as crazy as I can think of. So the constant for multiplying the x, I'm going to write pi x, I don't know, plus, and then the number is going to be 1 million. And I want this to be equal to 0. Okay, it doesn't matter. I can write it as complicated as I want. By the null factor law, this means that the solutions can be found by looking at the expressions inside the bracket being equal to 0. And those expressions are linear, so no matter how crazy they look, we can solve them. So, for instance, 3x minus 17 is equal to 0. That means if I sum 17 on both sides, that 3x is equal to 17. And that means if I divide by 3, because I don't want 3x, I want just x, that means that x is going to be 17 divided by 3. So this is one of the possible solutions. The other option will be that pi x plus 1 million is equal to 0. Okay, then I'm going to subtract 1 million on both sides. So I'm going to have that pi x has to be equal to minus 1 million. But I don't want to know how much is pi x. I want to know how much is x, so I need to divide by pi. So x has to be equal to minus 1 million divided by pi. So it doesn't matter how complicated I may make this look. At the end of the day, these are linear equations, and we know how to solve them. So if a quadratic function is given in factorized form, we can always apply the null factor law and find the solutions.